Okay, sorry. I think I've going here. Okay, so this is the second page. Not so worried about your definition here. Okay, here's what I want to talk about now. This idea of closure. So, it talks about if you take two even numbers and you add them, you're also going to get an even number. So we say that even numbers are closed under addition. If you do something to them and you always get the same type of thing that you started with, then we call it closed. And it gives, like I said, mathematicians like it because it kind of helps with that predictability and characteristics of numbers. So they want to know if odd numbers are closed under multiplication. So basically, the way mathematicians should kind of think this through is trial and error. Think about different types of odd numbers, positive, negative, whatever you want to do, and say, are we always going to get this type of thing? So, like maybe you start with 3 times 3, the same type of number. That's 9. Okay, that's odd. 3 times 5 is 15. Maybe for this seems like it is, right? So you have to try to find a way, and it says to explain it. And I thought this was hard. Basically, you're looking for the best thing to do is look for a counterexample. Because if it's counterexample, then it's not closed. It's easy to say it's not closed. Saying it is closed, actually, I really think this is kind of a jerk move to do because you really should have to prove it. But basically, if you have an odd group of odd things, you're still going to have an odd number. So if you said some sort of thing like that, an odd group of all things, that's good. I do not want you to get hung up on the explaining. I'm more into the true or false, and if it's false, come up with a counterexample. Okay, the counterexample say it can't be closed because here's one that's not. That's more what I'm looking for. Okay, so if you find two odd numbers that give even, that would be a counterexample, but that's not the case here. Okay, so we're only going to look at true or false. We are not going to give a reason with at least two examples. You should probably come up with the two examples. That's okay. But I don't want you to give a reason. That's hard. But you should think of different types of representatives, like the same type of number or one big and one small, stuff like that. But if it's false, I do want you to try to find a counterexample. I'm only going to go over the closure ones with you because that's the biggest thing. So let's talk about number 4. Whole numbers. First of all, you need to know what a whole number is. They'll start with a number with a hole in it. So 0, 1, 2, 3, all these. Are they closed under addition? So if I take a whole number and I add it to another whole number, will I always get a whole number? And the answer is yes, it is true. It is closed. Because if I take 0, which is the smallest, plus anything bigger, I'm not going to get an in-betweener number, right? If I take 0 plus 5, I get 5, which is definitely a whole number. Or a big one, 10 plus 35, that's 45, still a whole number. There's no way I can get a negative number, and there's no way I can get something in between. So the answer is true. It is closed under addition. We're going to skip ahead. I mean, you're welcome to do all these. If you take a quadratic and add it to a linear, could you get a cubic all of a sudden? And the answer is false. You cannot get a cubic because if you have a quadratic like x squared plus 1 and you add it to a linear like x plus 1, you get a quadratic. So there's your counterexample, x squared plus x plus 2, which is a quadratic and it's not a cubic. In fact, it would be impossible for you to get a cubic. So that's a definitely false one. The sum of a linear function and exponential function is a polynomial. That's also not one I had marked down for you to do. It is also false because you take a linear and an exponential. Exponentials are something like 2 to the x, and that cannot be a polynomial when you add it. Polynomials do not have variables in the exponent. So that is a false. And you can give an example of a linear plus 2 to the x. Okay, let's talk about 7. Closed under addition, polynomials. If I have a polynomial and I add it to another polynomial, will I get a polynomial? So if you go back to your definitions, polynomials all look like a number x to some number. And I could scroll back up here and show you. If I add any of these together, am I still going to get something that looks like this? Yes, because polynomials are based on addition anyway. I can't get one of those rules of a negative exponent or a rational exponent. So is it closed under addition? That's true. You could give a couple examples if you want, not necessary. Number 8, Is a whole number closed under subtraction? So 0, 1, 2, 3. Subtraction. Well, if I take 3 minus 1, that's 2. That is a whole number. But what happens if I take 1 minus 3? I get negative 2. This is my counter example. Negative 2 is an integer, which is not a whole number, so it is not closed. So it is false. It is not closed under subtraction. Addition is usually easier for closure to happen. Subtraction is a little bit, because order matters, and division, subtraction, division usually have more catches. 9. Is integers closed under subtraction? Okay. So now you're looking at your negative 3, negative 2, negative 1, 0, 1, 2, stuff like this. If I subtract these, will I get one of these? And I believe this to be true, because if I take negative 3 minus 2, I get negative 5, which is an integer. If I take 2 minus negative 3, I get positive 5, which is an integer. I'll never get something that has these in-betweeners. So subtraction is okay with these integers because of the negative signs. It wasn't the case with the whole number. So this one is a true. A quadratic subtracted from a cubic is a cubic. That will be true. You can look at some examples if you want. A linear subtracted from a linear is a polynomial. That is yes, because even if the linear term crossed out, technically a constant is a polynomial. So 11 is also true. A cubic function subtracted from a cubic function is a cubic. That is false, because if you take a cubic function like x cubed plus 1 and you subtract itself, you actually get 0, which is not cubic. That's a constant function. So this was actually false. So is the set of polynomial functions closed under subtraction? Well, this didn't give me a cubic, but is 0 technically a polynomial still? And the answer is yes, it's a constant polynomial. So as long as you have this as a constant polynomial, this is closed under subtraction, because addition and subtraction go hand in hand with negative numbers, and you can have negative leading coefficients. Polynomial functions are closed under subtraction. This one is a little confusing. If you thought 13 was hard, that is quite okay. This idea of closure, like I said, is a very advanced topic, in my opinion. 14, if you multiply 2 lines, are you going to get a quadratic? The answer is yes. 14 is true. Is integers closed under multiplication? If you multiply 2 integers, are you going to get an integer in return? The answer is true. That is closed under multiplication. Even if you multiply by 0 and get 0, it is an integer. It works. Would polynomials be closed under multiplication? You did a lot of examples with that on your last quiz with the rectangle method, double distributing. You always got a polynomial in return with bigger degree, but it is closed under multiplication. Now, it is not closed under division, and here is why. Because if you divide 2 polynomials, sometimes you got that remainder, which had a fraction, guys. We looked at those. This is dividing 2 polynomials. We said that is not a polynomial. You are not allowed to have variables in the denominator, so that is false. It is not closed under division. Oh, it said integers. Dang it. I was doing polynomials. I just did 19. Integers are also not closed under division, because think, while 12 divided by 3 is 4, and it works there, 3 over 12 is 1/4, which is not an integer. That is a rational number, so that is not closed under division. So it's a false. 18, a cubic divided by a linear is a quadratic. Sometimes, if it is a factor, but sometimes you have a remainder as well. So if you have a remainder, it is not true. Okay, so this is a lot of thinking questions. Some of it is a little annoying, like I said. This notes section is not my favorite. The ready, set, go isn't so bad, but I will go over the whole ready, set, go tomorrow for you.